Four-wheel steering, 2470, 2670, 2870. Since the introduction of the first four-wheel steer tractor, its field usage has grown from that of only a mover of primary tillage equipment to a point of sophistication that includes the handling of large row crop planters and cultivators. With this row crop evolution came the requirement for precision steering. Case engineers, together with the field service representatives, have very systematically studied this requirement and offer you, the service technicians, this systematic approach to making sure Case customers enjoy the most advanced steering system on four-wheel drive tractors marketed today. Let's see how it works. All of the rear steering complaints will fall into one of the four following areas. 1, rear wheel drift. 2, shimmy. 3, improper tracking. 4, jerky steering. This condition applies only to the 2470 and 2670. To properly define which area the steering complaint falls into, test drive the tractor yourself and execute all of the rear steering modes. Then have someone else drive the tractor while you observe the rear wheels as the tractor is being driven. This is what you will see. 1, rear wheel drift. When the tractor is driven in a straight ahead position, the rear wheels gradually move the tractor to the right or left. 2, shimmy. When the tractor is driven in a straight ahead position, the rear wheels are constantly moving to the right and left. 3, improper tracking. When the tractor has completed a turn and the front wheels are returned to a straight ahead position, the rear wheels do not completely return to the center position. They continue to turn the tractor similar to the drift condition. 4, jerky steering. When the tractor is turned right or left, the rear wheels seem to jump through the turn. Also, a loud cracking and snapping sound is heard. This problem is more noticeable at high engine RPMs. The important thing to remember when viewing this program is that we are dealing with two hydraulic steering systems that are connected by a mechanical linkage. The front system controls the rear system through this linkage. Therefore, if the linkage is binding, incorrectly adjusted, or worn, precision steering will not be maintained. Using this reasoning, it will become obvious the corrections for three of the problems, drift, shimmy, and improper tracking, are closely related. The first rear steering problem we will correct is the rear wheel drift condition. This condition is a result of linkage or cables being improperly adjusted, causing the rear steering spool to move slightly. Results are the wheels move in either direction. To correct, start the linkage check by aligning the front and rear wheels and setting the steering cylinder rods equally. Measurements must be equal between the cylinders on the same axle, but do not have to be equal between the front and rear axles. Next, disconnect the steering cables at all four wheels. Now, make sure all four joints are threaded 5/8 of an inch onto the cable. The easiest way is to measure from the end of the cable to the lock nut. Then check that the ball is free in the joint, but not sloppy. Replace the ball joints that bind or are too sloppy. Next, disconnect the cable ends under the instrument panel and check the ball joint ends. You check these joints the same way you did the ones at the wheels. Now check that the cable's exposed thread is 7/16 of an inch from the nut. Reposition the retainer nuts to obtain the correct length. Then check the lever control arm and the automatic quadrant for any side movement. To do this, it will be necessary to disconnect the tower link. If there is side movement, replace the parts, as worn parts can cause the valve spool to move and result in steering drift. Current replacement parts are furnished with bronze bushings for longer life. Next, check the steering hand lever position in the quadrants. The quadrant notches are bevel cut to firmly hold the hand lever in the notches. The hand lever should never make contact with the back face of the quadrant notches. If it does, replace it. Contact with the back face is an indication the notches are worn, which allows lever movement to be transmitted to the steering valve. Now, reconnect the cable ends to the quadrant. The next step will be to center the quadrant in the instrument panel notch. This can be done by first marking the center of the notch and then positioning the center of the quadrant notch on this mark. Then clamp the quadrant in position. Now fasten the ball joints to the front axle plates. And put the cables back in the front axle bulkhead. Leave the outer nuts loose and tighten the inner cable retainer nuts finger tight to remove any slack in the cable housing. The trick to the success of this adjustment lies in getting the cable square with the bulkhead to make sure you get the inner nut finger tight. Then tighten the inner retainer nuts one additional turn to tension the front cables. Now the clamp can be removed from the quadrant. Next, check that the quadrant is still in the center of the instrument panel slot. If it is centered, it is an indication that the front wheel cable tension is equal. At this point, check to make sure there is no movement in the quadrant lever when in the automatic mode. Movement indicates that the cables are still not properly tensioned. They are too loose. Give each cable another turn and then recheck. After the steering linkage has been properly adjusted and tensioned, tighten all of the outer retaining nuts on the front axle bulkhead. Once the front steering cables have been checked and adjusted, start checking the rear steering cables. First, check that the ball is free in the joint, but not sloppy. Replace any ball joints that bind or are too sloppy. Next, the ball joints must be threaded onto the cables 5/8 of an inch. Then disconnect the bell crank link. Now we will check the steering bell crank for excessive wear. Also check that it isn't frozen to the mounting shaft. Then check the bell crank shaft retaining holes for wear. If any of the parts show wear, replace them with new parts, which are heavier and have bronze bushings installed. The bulkhead has also been changed. The bell crank shaft is pinned to the bulkhead, preventing the shaft from rotating and wearing the retainer holes. The bell crank is heavier to eliminate flexing. Next, let's look at the override mechanism. To correctly check it, the complete unit must be removed from the tractor. To do this, remove the ball joint from the bell crank connecting link. Then disconnect the valve spool. The override mechanism can then be removed. Inspect all of the ball joints, shaft pins, and the retaining holes for sloppiness. If any of the parts show sloppiness, replace the complete override mechanism. The new override mechanism has self-lubricated bearings to prevent binding and wear to the shaft pins and retaining holes. Before reinstalling the override mechanism, it will be necessary to adjust the hand lever connecting link to 5 13/16 inches center to center. Then adjust the bell crank adjusting link to 6 1/8 inches center to center. After you've arrived at the 6 1/8 inch measurement, thread the lock nut against the ball joint and remove the ball joint. Next, measure the exposed thread on the link so you will know where to reinstall the ball joint after you get it through the firewall. We can now install the override mechanism. Then connect the ball joint to the rear steering hand lever. The next step will be to thread the valve spool onto the valve link until the measurement from the end of the spool to the center of the override pivot is 1 13/32 inches. You can now install the ball joint on the bell crank connecting link, getting the ball joint tight against the lock nut without disturbing the previous 6 1/8 inch measurement of the link. This measurement is very critical. Then connect the link to the bell crank. Now measure the distance from the bell crank to the bulkhead. Both measurements must be equal to within 1/8 of an inch. If not, recheck all steering cylinder measurements to make sure the wheels are in alignment. If the wheels are straight, adjust the hand lever link so that both ends of the bell crank are equidistant from the bulkhead within 1/8 of an inch. Once the bell crank is positioned, reconnect the rear steering cables. Next, fasten the rear steering cables to the rear axle plates. Put the cables back in the rear axle bulkhead. Leave the outer nuts loose and tighten the inner cable retainer nuts finger tight to remove any slack. Then tighten the inner retainer nuts one additional turn to tension the rear cables. Next, tighten the outer retainer nuts on each wheel. We are now ready to adjust the valve spool. Before you start, make sure the wheels are straight and the rear steer lever is in the automatic quadrant. Then, start the engine and operate at 1600 RPM. Now, slowly turn the rear steer valve spool outward, clockwise, until the rear wheels start to turn. Then, slowly turn the valve spool inward, counterclockwise, counting the number of turns, until the rear wheels move in the opposite direction. Next, turn the valve spool outward, counterclockwise, 1/2 the number of turns required to move the rear wheels. This adjustment centers the spool in the valve. After the valve spool is properly centered, hold the valve spool in position and tighten the ball joint lock nut. The next thing we will do is install the rear steer valve spool centering kit. The purpose of this kit is to maintain wheel alignment and reduce rear wheel shimmy. This completes the checking and adjustments for the rear wheel drift steering conditions. Next, let's look at how you can correct the shimmy steering condition. Basically, the shimmy condition is caused by the same incorrectly adjusted or worn linkage that caused drift. The major difference is that in the shimmy condition, you will find considerably more wear in the mechanical steering parts and linkage. To correct the shimmy condition, first, check the wheel alignment. Second, check the steering linkage and cables. Next, check the steering hand lever position in the quadrants. The hand lever should never make contact with the back face of the quadrant notches. If it does, replace it. Now, check the bell crank and bulkhead assembly. If any of the parts show wear, replace with the new parts that are heavier and have bronze bushings installed. Now for the override mechanism. If any of the ball joints, shaft pins, or retaining holes are loose or sloppy, replace the complete override. Remember, if a new override mechanism is installed, a valve spool centering kit must be installed. If the override mechanism did not need replacement and a shimmy condition is still present, adjust the rear steer valve spool for proper centering. And last, install a valve spool centering kit. To cure improper tracking, the following items must be checked. A, wheel alignment. B, cable position and tension. C, steering bulkhead and bell crank. The bell crank shaft may be frozen to either the bulkhead or bell crank. Also, the parts could be bent. Parts that are frozen or bent must be replaced. D, override mechanism. The override mechanism may be partially or completely frozen. If so, replace it. If you replace the override, don't forget the spool centering kit. The last steering condition we will look at is how to correct jerky steering on the 2470 and 2670. This condition is caused by too much hydraulic oil being supplied to the rear steering cylinders, causing the rear wheels to react much faster than the front wheels. When the rear wheels turn or react faster than the front wheels, the mechanical linkage shuts off the oil supply to the rear wheels until the front wheels catch up. Then the oil supply is again allowed to flow to the rear wheels. This constant starting and stopping of the oil supply is what causes the jerky steering condition. Since the cause of this condition is a hydraulic-related problem, the installation of a flow divider valve kit will correct this problem. Due to varying conditions, the flow divider valve will allow the operator to manually regulate the amount of oil being supplied to the rear steering cylinders. To install the flow divider valve kit, follow the instructions provided with the kit. After the flow divider valve has been installed, place the control knob at 7. This is not a final setting, but it is a good starting point, since the final setting is accomplished by the trial and error method. Now that we've discussed all 4 of the steering problems and their solutions, let's review the critical points. First, square up all 4 wheels. Second, before you start any adjustments, check all of the ball joints and cables to make sure they are not damaged or worn. If you don't, your adjustments will be in vain. Third, before you start adjusting, check your quadrant assembly to see that it is not worn or frozen up. If it is, replace it, or you will waste your time adjusting. Fourth, check the bell crank for wear before you start, or you will get into trouble with your adjustments. And fifth, make sure the override pivot mechanism works free but is not sloppy. If you fail to perform any of these 5 pre-adjustment checks, you are wasting your time and the customer's money. The most critical part of the override adjustments is getting the link measurements accurate. One final point. If you have done everything right, the rear wheels will return to within 1/4 of an inch of center. This is normal due to the neutral position of the valve spool. The case steering system on four-wheel drive tractors is the most maneuverable and responsive system ever designed. This program should help you, the service technician, keep it that way.